You're listening to Back to the Roots podcast with Brian Wood and myself, Mike Klein, and today we're sitting down with Eric Lee Mader from the Xerces Society. Eric, thanks so much for joining us today, and can you give a little bit of your background and what Xerces Society does?
Sure. So I guess I'll start with Xerces. Xerces Society is now a 46-year-old wildlife conservation organization. It's named after the now extinct Xerces blue butterfly, which was the first butterfly to go extinct in North America as a result of habitat loss. It was interestingly sort of a casualty of the Second World War, when the last of its habitat in California was paved over to build a naval base for the war effort at the time. And for roughly the first 20 or so years as an organization, Xerces was truly a butterfly conservation group made up primarily of academic researchers. And somewhere over the course of its lifespan, Xerces sort of reinvented itself as a full-fledged wildlife conservation organization, hired full-time staff and a full-time management team, and broadened its focus to work on invertebrate animals in general. And invertebrate wildlife comprise the largest group of living organisms on Earth, and yet they're historically overlooked in mainstream conservation. If you think about what insects do, what aquatic invertebrates do, these are the animals that build our soils. Mm-hmm. They're soil engineers. They're oftentimes the first stage in the carbon cycle. They pollinate crops. They filter water. They're food for other animals like songbirds. So they play this sort of essential role in the entire system of life on Earth. Within Xerces, we've got a few formal program areas. We've got people still working on butterfly conservation today. We also have people working on pesticide policy issues, conservation policy issues. Within the organization, our pollinator and agricultural biodiversity program is probably the largest program area, and that's the program that I co-direct. And we've got sort of this interesting structure where we have this co-director management style where my colleague Mace Vaughn, my co-director, manages most of our government relations and our work with the NRCS on USDA conservation initiatives and incentive programs for pollinator conservation. And I work more on the private sector side, working with individual farmers and working with food companies on large-scale sustainability efforts to protect pollinators and also increasingly beneficial insects for pest management within Xerces. I've been at Xerces now a decade. I come from a North Dakota family with roots in commercial beekeeping, with farming and ranching, and brought, I think, some of those sensibilities to what I do today at Xerces. Got sort of a complex trail of professional experiences prior to doing what I do now. Did most of my college work overseas in Japan and ended up as a crop consultant for the native grass and wildflower seed industry before working to Xerces. So it's kind of a complex web of backgrounds, both within Xerces and for me, that I think have brought us to where we are now with my program, which is, I think, a kind of trend-setting conservation model for bridging the divide between wildlife conservation and agriculture.
Mm-hmm. And I think that's one thing that with organic agriculture and having your buffer zones between your conventional neighbor is a huge opportunity to get, plant diversity in there for the pollinators, for the butterflies and things like that, which I see more and more of that happening on farms, which I think is really exciting because the pollinator issue is real.
Yeah, it is real. And I think this is the future of farming. And I say that with a certain degree of confidence because, as I mentioned, I work with major food companies. And, I work with some of the largest food manufacturers on earth, food manufacturers, for example, that source dairy, organic dairy from OV member farms. And the fact that we see now sort of commercial scale food production embracing this as a model, I think is really telling, because these companies are not investing in the creation of buffers for beneficial insects or pollinators just out of a sense of goodwill, although it is the right thing to do. I think increasingly it's recognized that the conventional agricultural models that we've built our civilization on have some fundamental flaws that are now increasingly visible in terms of soil degradation, in terms of loss of biodiversity, in terms of their impacts on human health. And I think there's now both this increased environmentalism and the sensibilities around that are driving this movement, but I think there are also there's a clear economic case to be made for the preservation of our natural resources, and agriculture is kind of ground zero for making that happen.
Mm-hmm. Can you talk a little bit about that economic case? And I assume when going to these companies that you're working with, that's the case that you're giving them, because in farming, just in general, especially with where prices are today, whether it's organic, conventional, it does not matter. If you're taking any land out of traditional, say, row crop, it's not economically feasible. You're probably going to run up against a lot of roadblocks. So I'm just curious what the argument that you're given is.
Yeah. So I think there are actually multiple arguments that we could look at. One is sort of the more superficial driver is, I think, consumer demand. And within the food industry today, as you guys know, organic, I guess to lump it all together, organic and natural foods are the growth sector within the food industry today. Conventional processed foods have flatlined in terms of their profit potential. And so companies are increasingly looking to organic systems as a profitable sector that they want to grow, and along with that comes the need to foster environmental and ecological resilience, because that's what organic systems are built upon. You can't just throw chemical inputs. You've got to actually build the system's ecology to make it work. So that's kind of the superficial part of what's driving this. There are also, I think, deeper and in some ways more troubling economic influences. One of those influences is what has happened to honeybee populations. Since about 1945 or 1950, we've lost about half of the managed honeybee hives in this country. And there's a whole range of reasons why we've lost them. We've lost them due to diseases, parasites, habitat loss, pesticide use. It's harder now to keep honeybees than it's ever been. And yet at the same time, we have this rapidly increasing acreage, this global acreage that requires insect pollination. If we look at almonds alone in California, there are now 900,000 acres of almonds in California. They're stocked at a minimum rate of 2 hives per acre. On a good day, there are maybe 1.5 million commercial honeybee hives in the United States that can be moved to California every year for that crop. So you do the math and you quickly understand that we're up against a wall. And the only way to sort of work our way towards a more sustainable system is now to look at alternatives like building habitat on farms, planting flowering cover crops, planting flowering hedgerows, restoring wildflower meadows adjacent to these almond orchards to sustain wild bee populations that can help supplement the pollination needs of that crop. Similarly, we can look at the pest management value of integrating more beneficial insect habitat onto farms. Within organic production, natural pest management is typically the baseline system we use for controlling pests. And there's this tremendous body of research. There's research going back literally more than 100 years demonstrating the value of native, wild, beneficial insects for managing pests. We know that if you've got a farm landscape that typically has more than 20% of the overall land base in some type of natural habitat, that you have measurable levels of beneficial, just wild beneficial insect pest management taking place throughout those crop fields. So there's, as we look to the growth of organic systems, there's an argument to be made for enhancing natural pest management. Even if we look at conventional systems, there's always this resistance that builds among pest populations. You can come out with a new chemistry, and very rapidly pest insects typically build up resistance to any new chemistry that we throw at them. And so the chemical industry has come up with this business model of constantly reinventing the classes of insecticides they use to counteract that natural selection and the buildup of resistance. Natural pest management with beneficial insects doesn't have that problem.
It won't evolve out of its management.
That's right.
No.
Yeah. So there are all of these different cases to be made for it from an economic standpoint alone.
And I think, when you talk about pollinators, the first thing you do is just think honeybee.
Correct.
But all the other pollinators that are around is what most people don't see, because the honeybee is the big visible one, that and the bumblebee.
That's right, yeah. And if we think about bees, within North America, there are roughly 4,000 species of wild bee. These are, our bumblebees. These are small ground nesting sweat bees. These are leafcutter bees. For a lot of crops, these wild bees are sort of the preeminent pollinators. If you look at alfalfa seed production, thinking about an audience that might be listening that has roots in organic dairy production and the role that alfalfa plays as sort of a top tier forage crop. Most alfalfa seed in the United States is produced with pollination by bees other than honeybees. Honeybees, as it turns out, are terrible alfalfa pollinators. They have this habit of robbing nectar from flowers without ever contacting the pollen-bearing parts of the flower. If you look at pumpkins or squash, there are native wild bees that evolved with those plants here in North America. They nest typically in the ground at the base of those plants. It's likely that there was this co-evolutionary process that occurred first in Central America or Mesoamerica, and then as native people expanded squash production across more northerly climates, these bees moved with those native people and moved with these crops. And even today, you can go out to big commercial scale pumpkin operations here in the Midwest, and you can find huge populations of these native squash bees nesting in the ground in those fields. The interesting thing about them is that they're active super early in the morning, so they tend to emerge in the summertime before the sun has even risen. They're out there pollinating those flowers. They do a huge amount of pollination, and then they typically go back in the ground by mid-morning. And so you end up with, pumpkin farmers who are renting honeybee hives to pollinate these crops, not recognizing that the wild bees came up at 4 a.m. and did all of the pollination
work
already.
So are these bees, you said wild bees, so I assume that the habitat is there for them, so they showed up. Or are these farms, say a pumpkin or squash farm, are they bringing in and planting, so to speak, these, the squash bee, for example? Or is it more like you're building the habitat and they will eventually find it and come?
Yeah, it's a little bit of each. In the case of squash bees, they strongly prefer to forage in squash or pumpkin flowers, and they have this amazing ability to find them even over long distances. So if you plant, say, pumpkins in rotation one year, and then you don't plant pumpkins the second year, those bees will emerge in the summertime, and they'll be out looking for those preferred flowers. And in the case of the squash bees, they will just fly miles across the landscape until they find the flowers that they like. Now, that's not necessarily true for a lot of our wild bees. A lot of them really are dependent upon on-farm habitat. They're dependent on flowering field borders. They're dependent on having flowering plants in pastures or in hay fields. They're dependent on, some of the weedy plants that you might find along fence rows. That habitat is really kind of the critical piece of the puzzle. And habitat, as you guys know, it's, we live in a landscape now where that's not nearly as common as it used to be.
Now, you were talking that you mentioned a model for an agricultural system, and a lot of what we've talked about so far are fruiting crops where a pollinator is needed, but a lot of the farmers that Mike and I would work with are you talked about alfalfa plants and that kind of thing, but row crop usage and hay fields. What kind of model would be recommended to somebody that, say, has 100 acres and basically has pasture and then some crop ground, and they're trying to feed their animals off of that?
Yeah, I think there's a few different cases you can make for incorporating habitat onto farms that can support pollinators, but I think have sort of broader goals. And I sometimes refer to this as the ecological infrastructure of a farm. And one of those concepts that I think is really important, even if you're not growing a fruiting crop, is the pest management value. If you look at soybeans in much of the Midwest and eastern United States, soybean aphids are a huge pest of the crop. But yet many producers don't experience significant impacts from soybean aphids. And there's a reason for that. The reason for that is because we've got typically pretty robust lady beetle populations in those soybean fields that are performing that natural pest management. The same is true, if you look at silage corn. Having habitat on the farm increases the populations of parasitic insects that can prey upon pests like corn earworm, some of the root feeding insects in corn crops. So you build these kind of multiple layers of benefits on the farm. So you've got this natural pest management system built into place. You've got some services for pollinators built into the place. I think there's also and I guess to get on a little bit of a soapbox here for a moment, I think since agriculture is the single largest land use on planet Earth, I think there's also a responsibility that we collectively have as stewards of the land to support wildlife in general. If you look at the trends, the global trends with wildlife today, there's a gigantic wildlife, what's called a meta-analysis, performed every 4 years by two organizations, the World Wildlife Federation and the London Zoological Society, that tracks the populations of thousands of species of animals on the planet. And what we've seen is that over the past 40 years, 50% of the wild animals that used to roam planet Earth have disappeared. Thinking about where we are today in the Midwest, one of the most iconic of those species is the monarch butterfly. And we've seen a 90% decline in monarch numbers over the past 20 years. And things like the Renewable Fuel Standards Act, which have increased the production of conventional corn and have led to just massive planting of herbicide-tolerant corn, which has reduced milkweed from those fields where it used to sort of persist along the edges, has driven this animal that so many of us grew up with, out living on the farm. Everybody remembers monarch butterflies. It's driven this animal to the point of decline where scientists are now actively talking about and actively predicting the timeline for its extinction. And I think that should alarm us. And I think that no matter what your sort of worldview, what your spiritual system is, I think we've got sort of this collective responsibility to leave the world at least, in a position where it's no worse than it was when we inherited it.
Agriculture uses the most land. Agriculture can do the most harm in the short amount of time, but it also has the opportunity to bring it back, to really make change for the better. When you mentioned the monarch butterfly, I don't know, we probably hatched about 40 last year, because there's all the land surrounding where I live is organic. So there's a lot of butterflies and there's a lot of milkweeds beside the road. So my wife will get the caterpillars and put them in and then hatch them and release them. But it's unbelievable how few you see anymore. And you don't realize it until you start really trying to see monarch butterflies. That's scary.
Yeah.
And what is that because of the BT corn, or is it just the amount of pesticides, or is it the herbicides? What is causing the decline?
It's mostly herbicides. So glyphosate. So as you increase the overall use of herbicides in conventional crops, things like milkweed that used to just grow up out in the corn, and you'd plow it under every year and it would always re-sprout. It used to persist along the edges of agriculture at a level that allowed the monarch to continue to survive even as we grew more and more crops. And now herbicides have really changed that equation, because now you're not just plowing it under where it's going to re-sprout. Now you're outright killing it from the fields. But, you said something that I think is worth focusing on, that agriculture can actively be I think, a significant solution. And one of the, as I think about what I do in my profession, I've been in sort of this role as an insect ecologist for years and years, and I've gone out and I've talked to people about how to plant prairie strips on their farm and how to restore habitat, which I think is still the right thing to do. But I think there's also this larger concept that we should recognize, which is there are models in this world for what, I hate to use sort of this kind of wonky term, but there are models in this world for what I refer to as biocultural landscapes. There are landscapes on planet Earth that have been in agricultural production for literally thousands of years. And the best of those systems don't only sustain biodiversity, but they actually enhance biodiversity. And we can use a lot of examples. We can use examples from Native Americans in the Pacific Northwest who grew camas, which is a native wildflower with a large edible bulb. It's got this beautiful blue flower in the springtime. And along with salmon, these camas bulbs were the primary staple food crop for those native people in the Pacific Northwest. Lewis and Clark talk about when they entered the Northwest, they found these large fields of this flowering plant, and they were so blue, there were so many flowers blooming that they looked like lakes from a distance. And the native people maintained these fields through burning, and they would dig the bulbs every year, and in the process of digging bulbs, parts of them break off, and so they would actually increase in numbers. Now, you can go to the Northwest today. Less than 1% of those remnant camas meadows still exist. But those also happen to be the systems that have all of the rare butterflies, all of the rare grassland songbirds, all of the rare bees. Those are the most biologically diverse ecosystems in the Pacific Northwest. And they are farm systems. You can look at Japan. And the Japanese have this concept of satoyama, which means village and basically village and mountain. And the Japanese have developed agricultural systems over thousands of years that mimic nature through like terracing of fields. They understood that, of course, water flows downhill. You can build rice terraces to trap the water. You can go to some of those rice paddies today, and those are the primary spawning grounds for certain fish. And without active rice production, you can't actually, without active rice production, there's nowhere for those fish to spawn. So you have an agricultural system that's not only feeding people, but it's over time evolved into active wildlife habitat. The Japanese also harvest their forests in very specific ways that increase light infiltration, and they're managed forests. The forests they manage for like mushroom production, for charcoal production. Those managed forests have more plant species in the understory than unmanaged forests. They have more wildlife in those managed forests than in unmanaged forests. These are systems that go back thousands of years. I know that you guys have, you've done some of your other podcasts. You've focused on, some of the plain-speaking communities, the Amish, the Mennonites. There's wisdom in those farm systems as well. Those are low-impact farm systems that have sustained people for thousands of years. And we've, as a society, as a culture, we've gotten off track from, I think, the wisdom of those elders, the wisdom of traditional ways of doing things that have allowed us to exist as a species. And we're now experimenting with ways of living and ways of producing food that have no precedent in human history. And I think even over the short time frame in which these systems have developed, there's a lot of trends, whether it's soil health, whether it's climate, whether it's biodiversity. There's a lot of trends that we should be scared about right now.
Mm-hmm. And I think there's a lot of work being done to get back, because there's a much more of a movement with the next generation coming on to try to get back to more diversity, more in working in harmony with nature versus the find the problem and kill it.
Yeah.
Because what you don't see when you kill something, what you don't see is how you just disrupted the whole system.
Yeah.
Let nature take its course, which it's easier for me to say that than probably a farmer that has weeds growing in his field. But, we have to work together with it. And like I mentioned earlier, the buffer strips. Like, I think we have a golden opportunity with the smaller organic farms in Ohio to get involved in something like your society, where we can really, we have this set aside strip of land that we're not using. Okay, it might only be a 20-foot buffer, but what can we put in there to help with the butterflies and the pollinators?
Yeah.
I think there's a lot of opportunities to do that.
Yeah, I think that's a great point.
I think the education is what right now that's lacking. I think the farmers would be really open to it, just nobody has pitched the idea to them. And you said you do work with NRCS?
Yeah, so we have the Xerces Society actually shares some staff positions with the NRCS. So we have folks in parts of the Midwest who are actually in NRCS offices, and they go out and provide the conservation planning assistance. There is there's a system of really good incentives right now for farmers who are interested in pollinator conservation or interested in creating more habitat for wildlife on farms. The NRCS has made this a priority over the past several farm bills, and I think the agency is now fully ingrained the concepts of pollinator conservation, and increasingly they're adopting this concept of natural pest management. And for things like flowering buffer strips, flowering hedgerows on farms, there are some good cost share incentive programs that are available to farmers right now. And I think the agency as a whole is very well trained and is at a point where I think they're ready to go out and deliver that support to producers who might be interested. Again, to get on my soapbox here for a moment, I think one of the challenges the NRCS is faced with is that they've got a huge number of staff vacancies within the agency right now. Funding for the agency has not remained very robust in recent years. And so I think that there are some struggles within the agency to deliver conservation support on the ground, which I hope that we can kind of turn the tide with that and rebuild the agency to its kind of full operational strength. But the people that are there, they're dedicated to conservation, they're dedicated to farming, and pollinators have definitely risen to the top of their priority list in recent years.
Now, okay, so I'm going to kind of change the subject a little bit, because you started off with saying that Xerces is evolved from butterfly when they started butterfly. I don't know what the right word would be, but butterfly habitat.
Yeah.
But anyway, it's evolved over time into working with invertebrates.
Yes.
And you talked about the building of soil life and feeding soil life, and that's one thing that we haven't touched on yet is the we've talked a lot about flying insects that people can see.
Yeah.
I want to go into a little bit on stuff we can't see.
Sure.
And all the stuff underneath the soil that is, I guess one of the places I wanted to go is you said that the farming systems where we're at now are so far away from where they were even 50 years ago. But now that organic agriculture has come back or brought back some of these old systems of farming. And now that there's been people that have really figured out how to manage that soil life underneath their soil, and they're doing just as well as a conventional farmer using every piece of science that you can possibly find.
Yeah.
And I think that's somewhere that in the case being made for why some of these old forms of managing land in a way that doesn't hurt, like Mike was saying, in harmony with nature, and using some of the principles that you guys are talking about is finally seems to be coming back. But how do we expand that more? How do we send that message out? It seems now that the big ag companies are finally talking about, soil health again.
Yeah. Yeah, Brian, I think you're touching on something really good here. So there has been this change in recent years where a lot of people are talking about soil health in ways that they're unprecedented in my lifetime. Mm-hmm. I think back to, college courses on soil science, and, it was all soil chemistry. And soils do have, they've got the chemical process, the physical process, they've got the biological process. And now a lot of people, the pendulum is swung the other way, away from chemistry and towards biology. And everybody's talking about glomalin and root exudates and mycorrhizal fungi, which is cool. And I think it's long overdue. And those things are an indispensable part of the construction and the life that soil is. But it is interesting to me that there's not a lot of dialogue on the animal life in soil. And the animals are just as indispensable as the bacteria and the fungi. If you look at a cubic foot of native prairie or native forest soil in the eastern United States, you would probably find, if you were to separate out all the living things in there, you'd probably find in that cubic foot easily 5,000 or more invertebrate animals. And those invertebrate animals do a whole bunch of things. I guess if we start like on the, maybe the top layer of the ground, there are, for example, one of our most diverse insect groups are beetles. And there happen to be, especially in the Midwest and the eastern United States, there's a huge range of beetles that feed on seeds. And interestingly, the feeding preference of most of these seed-feeding beetles is on things like lamb's quarters, shepherd's purse, basically, cropland weeds. And those seed-feeding ground beetles are really dependent upon cover on the soil surface, whether it's flowering cover crops, whether it's a grassy cover. But these things can make a huge dent in weed seed production in fields. If you work a little bit lower into the soil profile, you can find predatory beetle larvae in the ground that feed on things like slugs and can make a huge impact on slug and snail populations. It's interesting right now, the conventional soybean growers are all up in arms about slug outbreaks, right? The industry never had slug problems 30 years ago, but now they're using insecticide-treated seed on their soybean crops. And those insecticides in those conventional fields are killing the beetle larvae that used to suppress slug populations. You see these incredible photos now of coming out of Pennsylvania and parts of eastern Canada of machinery running through soybean fields covered in slugs.
Really?
And it's because these ground beetles are now decimated. So you've got this natural pest suppression happening at the soil level. You've got ants. Ants are arguably, along with plant roots and worms, arguably the most important soil engineers on Earth. There's a really there's this really, really old study from the early 1900s out of Massachusetts, which is just fascinating, which measured the amount of subsoil moved by ants in a Massachusetts farm field over the course of a year, and then calculated out what that looks like over an entire acre. And in one Massachusetts farm field, this study found that ants were moving about 30 tons of soil per acre per year. And you think about that, they are tunneling down into the ground.
30 tons per acre.
Per year.
That's like having an excavator on there.
It's like having an excavator, yeah. And so they're tunneling down into the ground, to excavate nests. In the process, they're moving that subsoil matter up onto the soil surface. They're covering the soil surface with, things from lower in the soil profile. They're burying organic matter in the process. You've got this massive soil inversion that's going on out in those fields all the time by ants. You can look at dung beetles. Nobody wants to give dung beetles any credit.
I finally, 3 years ago, I started getting dung beetles in my pasture field, and I was super excited.
Yeah.
Now when I put my foot on and pull that top layer of that patty back, it's just alive.
Yeah.
It's awesome.
If you don't like flies, dung beetles can do you a world of good.
I'm still looking to find a roller.
Oh, yeah.
I haven't found a roller yet. I just have the little guys.
Dung beetles are pretty rare now. Mm-hmm. They're not a common group of animals anymore.
And I think a lot of the wormer that is giving to livestock is actually going through the animal and will kill dung beetles in the manure.
That's interesting. I didn't know that.
Mm-hmm. Mm-hmm. Because I used a wormer on my steers that I was told does not affect dung beetles.
Huh. So that's good to know.
Mm-hmm.
Those dung beetles also, a lot of people are thinking about climate issues these days. Dung beetles can make a drastic difference in methane production from accelerating the decomposition of manure patties and of breaking them down before, they just sort of sit there and off gas into the environment. So all of these invertebrate animals at the soil level are having a huge impact.
Well, and one thing is you gave some awesome examples there, but you said there's 5,000 different species in 1 cubic foot of soil, native prairie soil. There is so much we don't know.
Yeah.
And I think just one thing that we've done as a society is we want to know what something does, and we want to try and pick that one piece of spider web up and understand what that one string does. But then we're not realizing that we're affecting the whole rest of the structure.
Yeah.
And that's just a societal thing that we want science to tell us what everything is doing so that we can, take a pill to improve our body, because magnesium's gonna. I'm just throwing an example out there.
Yeah, it's a reductionist mentality.
Right, exactly.
But
there's so much.
Great that we don't need to know everything that's happening under the soil.
Yep.
But I really liked what Jerry Brunetti used to say. I don't know if he was the founder of Agrodynamics. He passed away a couple years ago. But he said, look at your topsoil as an accordion. The more life you get in it, you are actually growing your topsoil. And he said the more life that's in there, the higher it's going to get, the better it's going to be produced, the more bugs and stuff are going to be in there. And he said it's all beneficial stuff.
Yeah.
He said once you start degrading your soil, that's when the negative things start happening. Yeah. He said if you feed the life that's there, it's all positive.
Yeah.
And in some cases with conventional agriculture, I liked one of the examples you mentioned where it wasn't milkweed, it was one of the weeds that is in a lot of corn and bean fields. Lamb's quarter. Yeah. And by spraying for weeds, essentially you are taking away the habitat or what is needed for the soil underneath. So they're going to leave, or they're going to die.
Yeah.
And so it's not only is herbicides and pesticides and salt-based fertilizers, are they killing some of the life that's underneath the soil. It's also taking away the habitat that is going to keep around the bugs that are going to help you. And the soybean example is perfect. And we're just shooting ourselves in the foot by continuing to use those practices in my mind.
Yeah.
Mm-hmm. I want to ask you about, is it neonicotinoids?
Neonicotinoids, yeah.
In soybeans?
Yeah.
Where I was talking to a guy that has commercial bee operation, and he lost 40% of his bees, and he said it is because of the high levels of that coming from soybeans. So the bees are actually dying from eating their own honey. So he is removing all the honey and feeding the bees over the winter because he's losing 40% to colony collapse from that. Have you heard? That was the first I had heard about that.
Yeah. So, I think neonicotinoids have gotten a lot of attention in recent years, and I think justifiably so. This is maybe, for me, one of the more troubling parts of a conversation like this is, I've talked, I think a lot of this conversation I've made reference to the value of habitat on farms and how important that is. But I think we're unfortunately faced with this situation where even if we can put in habitat, that habitat, unfortunately, is oftentimes in the line of fire for drift or for pulses of insecticides in groundwater that might be taken up by other plants. And neonicotinoids are, without question, a game changer. So neonicotinoids, for people who might not be familiar with it, they're basically a synthetic nicotine-like neurotoxin. They are unique because they are systemic in nature, meaning they are absorbed into plant tissue. They're sequestered in plant tissue. They might be sequestered in flower nectar. They might be sequestered in the pollen of plants. And they sit there in the plant. They're used prophylactically as a seed treatment in things like corn and soy, some other crops, before there's even a justifiable pest outbreak that might warrant their use, which is a different way than we've ever used insecticides. We've never, as a society, made the decision that we're just going to put insecticides out there preemptively. These things are really long-lived in the environment. Neonicotinoids are among the most long-lived classes of insecticides that we've ever come up with. These things can last for years. They're highly mobile in water. And if you look at some of the surveys that the U.S. Geological Society does of surface water conditions in the United States, I think that something like half of all surface waters in the United States have measurable concentrations of these insecticides present in them.
That's insane.
Now, we've made a decision as a society to embrace neonicotinoids. Neonicotinoids are now the most common class of insecticides on Earth. We made a decision to embrace them.
I want to stop you right there. We did not make a decision. Certain farmers and the chemical industry decided that this would be good, and now we have to live with them.
There's truth to that.
Brian doesn't want the blame for that.
Well, the thing is, we as a species, as a human species, we decided that neonicotinoids were a good alternative to older classes of pesticides because we don't see, and I'm going to speak carefully here so there's no confusion about what I'm saying. We, as a species, have convinced ourselves that these things have no acute toxicity to mammals. Now you think about that. We can apply these to crops. We don't notice any adverse impacts on ourselves. Now, acute toxicity, I want to point out, is different than chronic toxicity. So acute toxicity is like when you're exposed to something, do you have an adverse reaction? Chronic toxicity is a different story. Chronic toxicity is toxicity that builds up over multiple exposures over a long period of time. Neonicotinoids are a very new class of chemicals. We don't know. I mean, the chemical industry probably went out and did some tests on multiple generations of mice, and
I'm sure it was all good, and
Yeah. Mice do not live as long as my children live. And, I want my children to live to be 100. And what's going to happen to them with 100 years of exposure to these things? Certainly we know the science is telling us that neonicotinoids are not good for songbirds. They're certainly not good for honeybees. They're certainly not good for other beneficial insects.
But they're okay for humans.
Apparently. I think I struggle with this. And I'll get spiritual here for a moment. I struggle with this because I think if we define this as what it is, it's violence. And my spiritual tradition is nothing to brag about. I've fallen off the wagon in about every way possible. But the spiritual tradition that I have, I think that I've attempted to maintain some connection to is Quakerism, which is a tradition of nonviolence. And for me, when I look at the way we're applying these things on sort of a global scale today, really the only way that I can define it is violence. It's violence against the natural systems. It's violence against our children and our grandchildren. We're basically just handing the bill off to future generations to see what the long-term impacts of this are.
Mm-hmm. Mm-hmm. All in the name of making what? Making
money,
making
cheap food
and corn ethanol.
Yeah, because exactly. We need cheap food so we can use our money to buy crap we don't need.
Yeah.
Yeah.
Yep.
So that's the one thing that has bothered me growing up Amish. They're a non-resistant, non-violent, belief system, completely anti any violence. Yet chemicals and that type of farming and the GMOs, that technology is completely, it is, they never had any problems using all that technology while they're against 99% of other technology. And that has really bothered my dad over the years. He said, we're fine, we're absolutely nonviolence. But he said, when it comes to nature, we will kill anything that we need in order for money. And he said, that's wrong. And I think sometimes as a society it is easier to just not do the research, because just not knowing, you won't have the guilt associated with it.
Well, we don't have nobody wants to take the time to, like you were saying, chronic exposure. Nobody wants to take the time to figure out what 20 years of exposure to neonicotinoids or glyphosate or whatever it is. It doesn't matter. Nobody wants to take the time because they've got this new neat product that is going to make farming easier, and we need to get it out to people now. Yeah. Now, we need to make money on this. Nobody wants to take the time to do that 20 years of research. And that's why I stopped you earlier, just to say, when we're living with the effects of this stuff, it wasn't a choice that we made. And we're, like you said, we're passing the bill. Well, the bill is being passed to us, and then we're passing it on to the next generation, and then who knows how many generations this goes. You said, how long do neonicotinoids last in the soil?
Years.
We don't know half the length of this stuff.
But I think my goal in my life here is to take that bill that was handed down to me and pay a lot of that off, so I am not passing the full amount to the next generation. Mm-hmm. If we can cut down a little bit on what is getting passed to the next generation, is all we can hope and pray for.
Yeah, yep.
I think.
Well, leave the ground better than when you got it, and that's why I appreciate some of the work that you guys are doing and that you're talking about here. You're helping people do that.
Thank you.
It's really encouraging.
You made a point here, just to stick with this thread of violence for a moment. You made the comment about cheap food. And even if these neonicotinoids, even if our grandchildren turn out great, even if there's no adverse effects, what we've done in terms of a food model for our civilization is also a form of violence. And this issue of cheap food is one with significant impacts that we see all around us today. We can look in any of our communities and see the impacts of cheap food on people's health. And, all of these things, in my mind, are certainly connected. Mm-hmm. And I think, the ways in which we can build resilience and health in soils or in pollinators or in any natural system, I think those are the same strategies that we're going to use to I think undo the violence to our own bodies and to create I think a system of food production that's healthier for people.
Mm-hmm. Well, and they always say history repeats itself, or you can put the metaphor however you want. The pendulum will swing back around, and I think we're starting to see the groundswell of people that are saying, hey, we don't want this anymore.
Yeah.
And I mean, there's people that there's health clinics that look at food as medicine, healthy food as medicine. And there's the organic agriculture movement trying to improve the soil that you have and feed the underground life and the above ground life. And it all starts with the soil. And I think that's as much as we talk about being frustrated about some of the conditions we're in, it's encouraging to there's still encouragement out there that there's positives there.
And I think we had this conversation with Wes Jackson the evening on our patio. He said what used to be 5 people really talking about sustainability before the word was kind of ruined, is now thousands of people.
Yeah.
So, because I asked him, what are we going to do when the Wes Jacksons of the world, my dad, aren't here anymore? And he goes, well, you guys are taking over. You'll be fine. Like, what, me? No. But I think you touched on it, Brian. There is a movement, a positive movement. There's also a negative movement. I try to focus on the positive side of it, but because we can make a difference.
Yeah.
And I think with what the Xerces Society is doing, I think that is absolutely wonderful, because I think especially in the organic farming community, it's the living in harmony is talked about much more than in the conventional world. So for somebody like you to come in and talk to farmers in Ohio, I think there would be a lot of excitement among the farmers, because the amount of farmers that have gotten bees over the last couple of years is, oh wow, almost everybody has got a couple beehives, because they started reading about how the population is dying out. Now I've got a bunch of hornets. Those aren't pollinators, are they?
They typically pollinate a little bit, but they also control a lot of pests.
I was hoping there was absolutely no reason for me to not kill them.
They're food for birds.
They're nasty.
It's a certain beauty to the way they organize their lives.
Their nests are really cool.
Yeah, they are.
So,
Yep.
I think you guys are right, though. I mean, as much of a downer as I know I can be, this is a conversation that we wouldn't have had 10 years ago.
Mm-hmm.
And we, in our lifetimes, the three of us can sit here and look at each other, and we can all think back to a day when, and it was not that long ago, when you could go into a grocery store and there was no organic food in there. There was no Organic Valley in, a grocery store in Seattle, Washington, or in Boston, Massachusetts. And now, you can go to any mainstream grocery store in the United States and you can find organic food. You can find Organic Valley dairy products in those stores. And, it reflects, I think, a real change, and a change that refreshingly, happened through sort of a groundswell, sort of a grassroots movement. It happened from people out there on the land embracing this first and foremost and talking about it. And
it is our duty to keep carrying the torch forward. The generation before us started it. Now it is our duty to keep moving forward with this.
So. Yep. And I just, to wrap it back around, and then we can wrap it up, but I just, in the last 5 minutes, we talked about some of the positives, and that's the part, because as you look at some of these systems that are in place, it can get really, really frustrating, and you can also get really overwhelmed with the amount of negatives or things that can't be changed immediately.
Yeah.
It's just a societal thing that has happened, a change that has happened over 40 years now in agriculture, as the example I'm using. But there is that, as you said, that organic movement, and I mean like a natural groundswell of people, and it's growing. And that's the part we need to continue to focus on, is the positives, because if we get wrapped up in the negatives, then eventually you just drive yourself nuts.
Yeah, we have no choice but to work our way out of this.
Yeah.
So, well, we really appreciate the time. This was an awesome conversation.
Yeah, thank you guys.
This was
fun.
I think we could probably just keep going for another hour or two, because this is really interesting. Really want to thank you, and thank you for the work that you're doing. I'm excited about it, and thanks for spending some time with us.
Yeah, thank you both.